Assalamualaikum everyone. In today's video, we will be doing the past paper questions of the chapter of the gas laws. So let's get started. This is the first question. Let's read out the question. The two cylinders are connected by a thin pipe. One cylinder has the volume of 200 cm cube. We can say that, for example, this is V1 200 cm cube. Then contains air pressure at P. P1 is P. The other cylinder has a volume of 100 centimeter cube. So you can say the V2 equals to 100 centimeter. And the vacuum contains the vacuum means no air. So the diagram is shown. Initially the tap is closed. What is the final pressure of the air after the tap is open? So this is the tap. Initially this is closed. When this tap is open, so what is the final volume? Means what is the volume, or you can say the V2 here. Okay, in this question we will be using the formula of P1 V1 equals to P2 V2. I hope you remember that this formula is of Boyle's law. Let's do the working here. Okay, so the P1 is given 200, V1 is given 200, and the pressure is P. So 200 into P equals to P2. We need to find the P2, the final pressure, and the volume. They are saying that what will be the final pressure when the tap is open. It is written here that the final pressure of the air after the tap is open. So when the tap is open, so that 200, the volume of the air which is 200 will go through this line, or you can say this pipe, and enter the V2 side. So we will add this 200 with 100. 100 is given in the question. So 200 plus 100 into equals to 300. So the V2 would be 300. So now 200 into P means pressure 1 divided by 300 equals to P. 2020 cancel. So the pressure, or you can say the final pressure of P2 is 2 divided by 3P. Let's look at the options. So the answer we got is 2 divided by 3P. According to this, option B is correct, 2P divided by 3. So option B is correct for question number 1. Let's move to the question number 2. A fixed mass of gas is enclosed in a cylinder by a movable piston. So this is the fixed mass of gas, a cylinder, a piston, and the gas. The piston is moved so that the volume occupied by the gas increases. To increase the volume, the piston is being moved and the temperature remains constant. What happens to the pressure of the gas and why does this happens? So they are asking that what is happening to the pressure of the gas. The temperature is constant. So you know that pressure is directly proportional to volume. It means now they are saying that the piston, the volume occupied by the gas increases. The volume increases means that the pressure decreases. So when the volume increases, pressure decreases and the temperature is constant. So according to this, we will look at the MCQs where the pressure decrease option is present. They are A and B. The molecules, what is the reason of the decrease in pressure? The molecules move more slowly? No. The molecules collide with the piston less frequently? Yes. So option B is correct for question number 2. Let's move towards question number 3. A airtight container holds a fixed mass of gas. Its pressure and volume are measured on four occasions when the temperature is 20 degrees Celsius. So the results are shown in the table. Three sets of reading are correct. Which set of reading is not correct? Three sets are correct and one of them isn't correct. So for this, what you have to do is to use this formula, which is PV equals to K, or P1 V1 equals to K, and the K is the constant. So you need to multiply this pressure by the volume. The answer where the K constant is different is not correct. So let's do the multiplication using calculator. 120 into 36, we get the answer, which is 4,320. Then 100 into 48, we get the answer 4,800. Then 80 into 60, we get answer again 4,800. Then 60 into 80, we again get the answer 4,800. So option B is correct for question number one or question number 3. And in this option B, we get a different value for the constant K. So that is the set of reading that is not correct. Then let's move towards question number 3. The diagram shows how the pressure of fixed mass of gas varies with the volume at the constant temperature. So this is the diagram shown. What is the volume of the gas when the pressure is 20 kilopascals? So when the pressure is 25 kilopascals, what is the volume of gas? You can see that this is 25 kilopascals. Now, when you move here from in the row of 25, my pen, I don't know why it is so thick. You need to find the volume when the pressure is 25. So the formula would be pressure is inversely proportional to the volume. And you need to find the volume when the temperature is constant. In this case, P into V equals to K. You will rearrange the formula. Just a second. Okay. Here you will use the formula, which is P1 V1 equals to P2 V2. So the P1 would be, you will be taking P1 V1, any 2 points from the graph. You can take 2. Yes, you can take the P1 as 50 and the P2 or the volume, which is V1, as 20. So this is the point which which I just clicked using this yellow color, where the value of the volume is 20 and the value of the pressure is 50. So 50 into 20 are P1 V1, and then the P2 V2. P2 V2 you need to find, and P2 is given 25 kilopascals. So 25 into V2. These 2 points which I have taken as P1 V1, you can take these 2 points from any point given on this curve, which is drawn on the graph. So I have taken this point which I have highlighted using yellow pen, which is 20 volume and 50 pressure. So 50 into 20 divided by 25 equals to V2. 25 ones are 25 twos are 2 twos are 4, 40. So 40 answer is correct for question number 4, which is option D. Then let's move towards question number 5. A gas occupies the volume of 2 meter cube in a cylinder at a pressure of 240 kilopascals. A piston compresses the gas until the volume is 0.50. The temperature remains constant. What is the new pressure of the gas? So firstly, the volume is given 2 and the pressure is given 240. A piston compresses the gas until the volume becomes 0.50 and the temperature is constant. And what is the new pressure? For this, you will use the formula P1 V1 equals to P2 V2. So P1, you can see V1 is given 2 into P1, which is given 240 equals to P2. You need to find this P2 and V2 is given 0.50. Okay, now you will multiply them. Firstly, 2 into 240, which would be 480 divided by 0.50 equals to P2. So when 480 is divided by 0.50, the answer comes pressure 2 or P2 equals to 960, which is option D, which is correct for question number 5. Then let's move towards question number 6. The conditions are at the bottom and at the surface of the lake are given in the table. The conditions are given in the table. The temperature, bottom of the lake temperature is 10 degrees Celsius and pressure is 500 kilopascals. And at the surface of the lake, the temperature is 10 degrees Celsius and the pressure is 100 kilopascals. So a bubble of water, a bubble of volume 1.0 centimeter cube forms at the bottom of the lake. What is the volume of the bubble as it reaches the surface? Okay, so again, in this you will use the formula P1 V1 equals to P2 V2. The first pressure is given 500 and the second pressure is given 100. The first volume is given 1 and the second you need to find the second volume. So first pressure 500 into first volume, which is 1, equals to P. You need to find the volume and the pressure is given 100. So P2 is given and you need to find this V2. So 500 divided by 100 equals to V2. So its answer would be 5, which is option D, correct for question number 6. Then question number 7, the last question. A gas is trapped inside a cylinder by a movable piston. The length of the gas column is 20 centimeter and the pressure inside the cylinder is P. So the pressure is given P, length is 20 centimeter and the piston is movable. The piston is pulled out a distance of 30 centimeter so that the length of the gas column is now 50 centimeter. The temperature of the gas do not change. The temperature is constant. Do not change means it is constant. What is the new pressure? Now you need to find the new pressure. Okay, now to find the new pressure, what we will do is use again the formula of P1 V1 equals to P2 V2 and P1 V1 equals to P2 V2. Now the P1, you need to find the new pressure. For example, consider, it is given that the P1 is P and this V1 is 20. The initial length, the initial length is the initial volume equals to P2. You need to find the P2, new pressure, equals to V2. So this V2 would be 50, the new length or the new volume. So P into 20 divided by 50 equals to P2. 0, 0 cancel. So we got 2 divided by 5 P equals to P2 or the final pressure or the new pressure of the gas. So when you can see the options are given in decimal. You have to divide this 2 divided by 5, which gives 0.4. So the 0.4 P is the correct answer for question number, I think, 7. So option A is correct for question number 7. I hope you understood these questions and your concepts regarding this chapter would be clear. Thank you.